Hello guys, welcome to Photons, laws of photoelectric effect. Now, straight up for the first law, we have that the photoelectric current, which is IP, is directly proportional to the intensity, which is L, intensity. Now here, for photoelectric effect, the photon knocking out an electron is a one-to-one interaction. One-to-one. That means that only one photon can knock out just one electron. Doesn't matter if the photon has very high frequency, very much energy, but still in the end one photon can only knock out one electron from its orbit. That means to increase the photoelectric current, that means first we require more photoelectrons, and we can get more photoelectrons by knocking out more electrons from the metal surface, which overall means we need more photons. So we can get more photons by increasing the intensity of the source, right? So that means that the photoelectric current is directly proportional to the intensity, because the more photons we have, the more photoelectrons we get, thus there will be more photoelectric current. Now for the second one, kinetic energy is directly proportional to the frequency. Now here, for a photon with very low energy, less than the uh, work function, right? It will just vibrate the electrons. But for an energy equal to the work function, it will just make the electrons just emit out of their orbit. But for the energy having greater than 5 the work function, they knock out the electrons, and the electrons will get some of that energy and travel some distance. And since E equals to HF, here that means the more frequency we have, the more energy we'll have. Thus, when we knock out an electron, the more energy we have, the more the electron gets knocked out, right? And since the electron is traveling, that means it has some kinetic energy, and this energy converts into that kinetic energy of the electron. So that means more energy we have, the more kinetic energy we have. And since H is constant, that means the more frequency we have, the more kinetic energy we have. And similarly, vice versa for when low frequency, right? So this is also verified. Now for the third one, the stopping potential is directly proportional to the frequency. Now, first of all, what is stopping potential? It is the potential applied to stop the photoelectrons from moving out, right? Because when a photon knocks out an electron, as I said many times, it travels some distance, and the stopping potential is the potential to stop the electrons from moving, right? And here, that means the more kinetic energy of the electrons we have, right? That means the more speed, the more kinetic energy a electron has, that means the more stopping potential we need, right? Because if they have low kinetic energy, we can apply just low stopping potential. But if they have a high kinetic energy, we also need high stopping potential. That means, first of all, stopping potential is directly proportional to kinetic energy. And here from the second law, we know that kinetic energy is directly proportional to the frequency. So overall, that means that stopping potential is directly proportional to frequency. That is it for the laws of photoelectric effect, and you can in the examination stretch out the details and get the marks, right? And this is it for today. If you learned something new, please like and subscribe. Thank you.